In this video, we're ready to do another example of proof using mathematical induction. In this case, we are doing a proof of a series, but the series in this case is geometric in nature, which means it has exponents in it. So it's a little bit trickier at the end of the proof, in my personal opinion, from my experience with how students have done. The first part of the proof is to set the anchor or the base case, which means you prove the statement true when n equals 1. So the left side of the expression 1 plus 3 plus 3 squared plus the dot dot dot. The dot 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 means it's expandable or contractible on the left hand side. Since we are only talking about n equals 1, that means we're just talking about the first term, so we just use the 1 from right here. The right side requires us to plug in n equals 1. When we do so, 3 to the first power is 3 minus 1 is 2 times 1/2 is 1. We get 1 equals 1. Next, we need to do the inductive hypothesis. The inductive hypothesis is when we take the value of n and substitute in k. So we would just get the left side of the expression written out, the only difference being k instead of an n, and the right side written out, again, the only difference an n replaced with the letter k. Next, we will write our prove statement. This is what we're trying to prove. So in order to do this, we write out the left-hand side of this equation, and we keep going all the way up till we get to the expression that has, instead of n, k plus 1. So 3 to the k plus 1 minus 1. On the right-hand side, substituting in for n, we'd get 1/2, 3 to the k plus 1 minus 1. The left-hand side can be simplified. 3 to the k plus 1 minus 1 is 3 to the k. The right-hand side, just leave it alone. To do the proof, let's start with the left-hand side of our proof statement. Now keep in mind that 1 plus 3 squared dot 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 all the way up to 3 to the k. In here, there's actually an expression 3 to the k minus 1. So when I write the left-hand side of this prove statement, it really includes the entire inductive proof, which I have highlighted here, all the way up to 3 to the k. The left-hand side of the inductive proof is the part that's highlighted, so it can be substituted with 1/2, 3 to the k minus 1. Shown there. Bring the 3 to the k down, and now it's just a matter of simplifying this expression to see if I can get this equal to the right side of the prove statement. First, I need to distribute the 1/2. So 1/2 times 3 to the k is 1/2 3 to the k, and 1/2 times negative 1 is negative 1/2. Bring down the 3 to the k. Now I like to think of 3 to the k as 1 3 to the k, or 1 times 3 to the k. That allows me to help combine like terms. The like terms I have here are 3 to the k's. Well, think of 3 to the k's as apples. If a 3 to the k was an apple, I have a half an apple here, and I have one full apple here. 1/2 an apple plus a full apple is 1.5, or 3/2 apples. Of course, bring down the negative 1/2. Noticing the right side of the proof statement has a 1/2 factored out, it would next make sense to factor out a 1/2 out of this term. So taking a 1/2 out of 3/2 times 3 to the k would simply leave you 3 times 3 to the k, and taking a 1/2 out of the 1/2 leaves you with 1. So that's what we get there. Now to combine the 3 times 3 to the k, think about 3 as 3 to the first, and then still times 3 to the k. Then think of your exponent properties. When you're multiplying numbers that have the same base, keep the base and add the exponents, which gives us 3 to the k plus 1. This expression now is equal to the right side of the prove statement, which means I have proven the statement 1 plus 3 squared plus dot 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 3 to the n minus 1 is equal to 1/2 times the quantity 3 to the n minus 1 for all values of n such that n is an element of the natural numbers. Celebrate your successes. Be happy. Don't worry. Be happy.